So in the previous class, we have discussed what is the sample space and the event. So whenever we conduct the experiment, all possible outcomes are in the sample space. Okay. So if you are interested with the some of the outcomes, that outcomes will be placed in the events. Okay. So events will be subset of sample spaces. Okay. And we also discussed that the events will describe the characteristics of outcome of the experiment. Okay. So for example, whenever we are conducting the experiment of throwing a die, say the sample space will be having the values 1, 2, 3, 4, 5, 6. These are the possible outcomes of the experiment throwing a die. And for example, our event is getting the value greater than 3. So in that case, the event will be 4, 5, 6. This is the event we will be having. Okay, so what is this? The event will describe the characteristics of the experiment, and also it will also give us the properties of the experiment. So that is why events are very important. Here events will give us the describes the characteristics of the experiment, and also it gives us the properties of the experiment. Okay, so and what is the importance of random variable here is we will be representing the events in some probabilistic manner. That is, we will be assigning some numerical to the event. Okay, so that is why what is the importance of assigning numerical to the event here is whenever we have to solve the problems, it act as a powerful tool. Okay, so it gives the solutions in practical probabilistic gives the solutions of practical probabilistic problems. Okay, so that is why the random variable or random process is very important here. So what is that we are doing here? We are assigning some numericals to the events here. Okay, we are just defining the events in some different manner. Okay, what is that we are doing? We are assigning some numericals to the events here. Okay, so now we define what is random variable. So the random variable is nothing but a real function of the elements of sample space. What is random variable? Random variable is real function of the elements of sample space. Yes. Okay. So here the random variable we usually denote with the capital letters, and any values, okay, the particular values of random variable we denote with the lowercase letters. How we define the sample space with a capital letter, here also the random variable will be denoted with the sample space, and elements of the sample space will be denoted with the lowercase letters. Here also any particular value of random variable will be denoted with the lowercase letters. Okay, so for example, we have an experiment. The experiment is having the sample space ES with elements small s. Small s are the elements of the sample space capital S. Okay. So what is that we are doing? We are assigning a real number to every element of the sample space. How do we assign here? We are assigning it as x of s. Okay. So what is this? The x, capital X is nothing but the random variable. It is function of small s. Okay, so small s are nothing but the simple events or the elements of sample space. So this x of s is called the random variable. So the random variable is what? It is a function. This will map all elements of sample space into the points on the real line. Okay, so that is why the random variable is very important here. What it will do? It will map all the elements of sample space onto the points on real line. Okay, so now here we consider the example. So what is that here we are doing? We are throwing a die and tossing the coin, both we are doing. Okay, so we are when we throw a die, so what is the possible outcomes? We will be getting 1, 2, 3, 4, 5, 6. Okay, so when you toss a coin, what are the possible outcomes? We will be getting head or tail. Okay, so here the random variable is defined. It is a function, no? So the random variable is defined such that whenever we get a head, the value should be mapped to the value on the die. Okay, since we are throwing both head and coin, coin and die, yes or no? So whenever we get a head, and what is the value? Because the random variable will map the sample space onto the real axis. Okay, whenever we get the head, it is mapped to the value whatever the value is shown on the die. Okay, whenever we get tail, okay, so it is mapped to the negative values, and the value will be equal to the what is the value we are getting on the die, twice of the value we are getting on the die. Okay, so whenever we get head, it will be mapped to the positive value, and the value will be equal to whatever value showed on the die. Whenever we get a tail, it is mapped to the negative value, and the value will be equal to twice the value showed on the die. Okay, so this is the function that is called random variable. Okay, so here these are the possible outcomes. Since we are throwing both coin and die, so when we have the what are the possible outcomes here is 12. There are 12 possible outcomes. Okay, and just now we have discussed that whenever we get head, it is mapped to the positive values, and the value is equal to whatever value displayed on the die. So all these values are mapped to the positive values, so 1 to 6. Whereas whenever we get tail, it is mapped to the negative values, whereas the value will be equal to twice the value showed on the die. So it is mapped to the value twice of the value which is you are getting on the die. So it is mapped to -2, -4, -6, -8, -10, and -12. Okay, so one more thing you have to observe that here, how many elements you have in the sample space, the total number of elements in the sample space will be equal to 12. Okay, so how many elements it is mapped on to the real axis? See here, this is called the random variable. So this is the function we denoted like this here. This function will be mapping the sample space onto the onto the real line. Okay, so the values on the real line. Okay, so here if you observe how many values you have totally, the 12 values. So the sample space with the 12 values is mapped to the 12 values on the real line. Okay, so this is the one of the example. The other example is that here we are taking a wheel of chance. The wheel of chance is numbered from 0 to 12. Okay, so the sample space is defined here is like this: x of s is equal to s square, x of s is equal to s square. So what type of, here you see we are representing the sample space using rule based method. Okay, whereas in the previous case, the sample space is represented by using tabular column method, means every element of the sample space will be displayed. Okay, so that is called tabular column method of representation. Whereas in the rule based, we are using, this is called rule based method of representation. Okay, so here what is the sample space defined? The random variable is defined as x of s is equal to s square. So the sample space will be mapped put to the real line, that is 0 less than x less than or equal to 12. So what is the sample space? 0 less than s less than or equal to 12. Here it is mapped put to the real line 0 less than x less than or equal to 144. Okay, so this is the other example. So like that, every element in the sample space is mapped put to the real axis. Okay. So this is called the random variable. Now we'll discuss what is the condition for a function to be random variable. So for a function, any function to be random variable, what is the first condition is the function should be single valued function. It should not be multi-valued function. So what is single valued function? The single valued function is that every element of the sample space is mapped to only one value. Okay, it should not map to two values. Every element in the sample space should map to only one value. So that is called single valued. Okay, so if it is mapped to more than one value, then it is called multi-valued. Okay, so what is the first condition for a function to be random variable here? The function should be single valued function. It should not be multi-valued. Okay. The second condition is that, for example, we have the sample space x less than or equal to x be an event for any real number x. Okay. Then what happens here? This set corresponds to those points s in the sample space for which the random variable x of s does not exceed the number x. Okay. It means that if your set is having x number of elements, the random variable x of s will also does not exceed the number of elements in x. Okay, just now we have discussed that our sample space is having 12 elements. It is mapped to 12 elements. Okay, so that is that random variable should have the values less than or equal to number of elements in the sample space. Okay, so and whatever probabilities you'll be having to each and every event, that the same probability will be having for the sample space also. Okay, so for example here x is, we are throwing a die, so what is that outcomes here? We are getting the outcomes is equal to 1 2 4 5 6. These are the outcomes when we throw a die, yes or no? So if it is mapped to, for example, we have defined the sample space x of s is equal to what? S square. If we define like this, okay. So what is our what is our random variable x now? The random variable x will be having 1, 4, okay, 9, okay, 16, 25, and 36. These are the elements. Okay, now if for example our one probability of 1, what is the probability of 1 is 1 by 6. What is the probability of 1 here? Probability of 1 will be 1 by 6 only. Okay, what is the probability of 2 here is 1 by 6. Probability of 4 here will also be 1 by 6, like that. So whatever probability you will be having the elements, okay, the same probability will be having for the elements in the random variable. Okay, so this is our second condition. What is the third condition is that the probability of event x is equal to infinity and x is equal to minus infinity will be 0, because we don't have any event at x is equal to minus infinity, yes or no? Similarly, we don't have any event with x is equal to infinity. So probability of x is equal to minus infinity is equal to 0. Probability of x is equal to infinity is also 0. Okay, so these are the conditions that for a function to be random variable. What are the conditions? The first condition is it should be single valued function. The second condition is number of elements in the sample space should be equal to number should means that the number of elements in the random variable should not exceed the number of elements in the sample space, and whatever probabilities we have for the elements in the sample space, the same probability will be assigned to the elements in the random variable. Okay, and that is our second property. The third property is that we don't have any event with x is equal to minus infinity with x is equal to infinity. So probability of x is equal to minus infinity will be equal to 0. Probability of x is equal to infinity is also equal to 0. Okay, now we'll discuss what are the different types of random variables. The first one is discrete random variable. So the discrete random variable will be having the discrete values like this. So the discrete random variable, for example, x of s is given as minus 12, minus 10. These are the discrete random variable, that is you can able to count it. Okay, so and it is having the discrete random variable, discrete values. Okay, and we know that how do we get random variable? Where random variable will be getting by mapping every element in the sample space onto the real axis, yes or no? So what type of sample space we should have to get the discrete random variable here is, we can have the to get the discrete random variable, we can have discrete sample space or continuous sample space or mixture of both discrete and continuous sample space. So with this sample space we can obtain the discrete random variable. For example, we take the continuous sample space. What is the continuous sample space? We have discussed no just now, the numbers on a wheel of chance. The numbers on the wheel of chance is denoted as 0 less than s less than or equal to 12. Okay, so now we divide these numbers into two parts. The first part is having the values 0 less than s less than or equal to 6. This is our first part. This first part is assigned to the value 1. Okay, and the second part is having the values 6 less than s less than or equal to 12. This is our second part. It is mapped to the value -1. Okay, now if you observe what is the random variable here, the random variable is having only two values, 1 and -1. Okay, so how do you got this? We got this from continuous sample space. So the way of representing the sample space like this is called continuous sample space. Okay, and like that we can obtain a discrete random variable from continuous sample space, discrete sample space, or mixture of both continuous and discrete sample space. Okay, and similarly we have continuous random variable can be obtained only from continuous sample space. It cannot be obtained from discrete sample space. For example, you see here the continuous random variable is can be obtained only from continuous sample space. Okay, since it is continuous, it cannot be obtained from discrete sample space. Okay, and the next type of random variable is mixed random variable. So in this we will be having both continuous random, it will be having two parts. So the first maybe one or some of the elements will be in the discrete in manner, some of the elements are in continuous manner. Okay, so this type of random variable is called mixed random variable. Okay, so this is having very least importance. It is mostly used in some of the practical problems. We will be having this type of random variable. Okay, so for example, you take this is the sample space. What type of sample space it is? It is discrete sample space. Okay, now the random variable x of s is defined as s cube. So what is the random variable here? It is s cube. Now say for example, probability of 1 is given as 4 by 24. These are the probabilities given, okay, in the problem. So probability of 1 is given as 4 by 24. Probability of 2 is given as 3 by 24. Probability of 3 is given as 7 by 24. Probability of 4 is given as 10 by 24. Now we will be obtaining what is the probability that x is equal to 1 will be 4 by 24 only. Probability of x is equal to 8 will be 3 by 24, like that. Okay, so now probability of uh, random variable to be equal to 1 is equal to means from 1 only we got 1, no? So this random the what is the probability we have for 1 will be having for same 1 here. Probability for 2 will be having for 8, so it is 3 by 24. Okay, 3 by 24. See here, probability of 3 is assigned to see probability of 3 is 7 by 24. No, here also probability of x is equal to 27 will be same. What is the probability of 4 will be assigned to what is the probability of random variable getting 64 is equal to 10 by 24. Okay, so like that there is one to one mapping of discrete points from the sample space to the random variable. Okay, so that is the example. So what is that we have discussed? We have discussed that there are three types of random variables. That is a discrete random variable. Discrete random variable will be having discrete values. Okay, and just now we have discussed that the discrete random variable can be obtained from continuous sample space, discrete sample space, and mixture of both continuous and discrete sample space. And we also discussed that uh, continuous random variable will be having continuous range of values. Okay, so we will be representing continuous random variable with a rule based method of representation. So since it is having continuous values, so it cannot be represented from discrete sample space. Continuous random variable can be obtained from only continuous sample space. What is mixed random variable? Mixed random variable will be having both continuous and discrete random variables. Okay, so some of the terms are in discrete in nature, some of the terms are in continuous in nature. Okay, so it can be obtained from both continuous and discrete. Okay, and it is having very least important. It is mainly used in some practical applications. We are using this mixed type of random variable.